Okay, we are just gonna go over some basic terminology for geometry today and start with our first, start with our first lesson. So right here are just some 4 definitions we're gonna run through real quick. A line segment has 2 endpoints. Neither point goes on forever. They both have an ending. And so that's a line segment. You need to know what the notation is of these words because that you'll see a lot in examples. So the notation of this line segment would be you write AB because those are the letters, and then it's literally just a line over top of it. If you see a line over top of 2 letters like this, you automatically should know they're referring to a segment, which means they have 2 endpoints on each side. A ray has an endpoint, but then it goes on forever in the opposite direction. So the notation, you always have to start with the endpoint for a ray. So we're gonna start with M because that's the point that's not going on forever, MN, and that's gonna have an arrow. 1 arrow because it's only going on forever in one of the directions. So again, that's the difference between the segment notation and the ray notation. If you see one with 1 arrow, it's referring to a ray. Opposite rays mean there's 2 of them. So the endpoint in this case would be T, and there's a ray going on in the left because it goes on forever from T, and there's also a ray going on in the right. So we have 2 rays going in opposite directions. So to write both of those out, again, you start with the endpoint. The endpoint would be T, and it's TS goes on forever. And then TU goes on forever. And again, I'm drawing the arrows in the direction that they are going on the paper. So again, a ray has an endpoint, and then it goes on forever in the other direction. In this case, there are 2. That's why it's called opposite rays. An angle is a measure. So this would be the angle here. This is measured in degrees. It could be 30 degrees, 50 degrees, 42 degrees. And the notation for an angle, there's multiple ways. So in this angle in particular, you could say it's angle. So we're gonna use this symbol for angle. Angle 2, you can call it 2. You can call it angle Q, because it's also labeled with a Q, or you can use all 3 of the letters. When you use all 3 of the letters, the letter with the angle has to go in the middle. So Q has to go in the middle. So it'd be RQP, angle RQP, or you can do the other way. You can say PQR. But again, it has the angle, the letter where the angle is actually being formed has to go in the middle. But these are all the same way to write this angle. Okay, ignore the bell there. So on the next page, this is just kind of like the first theorem we're going to go over, and it's basically with a segment. So again, a segment has 2 endpoints. So if I look at this example here, we can form rays. Like we could have ray BA because it's going on forever in this direction. We could have ray BC. Let me see here. Yeah. So we do have rays, but we also have a segment. From A to C, from the length A to C, we have a segment here because we have 2 endpoints. So what this theorem is telling us is we can take the first part, AB, segment AB, so I'm going to put that little line over there to say it's a segment from A to B, plus the segment from B to C, so again, put a little line over that, equals the length of the entire segment, AC. So basically it's just saying that if you add up the 2 segments, it'll equal the length of the entire segment. So we're going to use that theorem to answer the following questions. So for this first one, they tell us AB is 12, so the length from A to B is 12, and the length from B to C is 7. Find the length of AC, which is basically the length of the entire thing. Well, if this is 12 and this is 7, the length of the whole thing is going to be 19. Because again, you're just going to add them together, and that'll give you the length of the entire segment. The next one, AB Now we don't have the actual length. Instead, it's represented by 4x plus 9. BC is represented by 5x plus 2. And it does tell us the length of the whole thing is 56. So from A to C, that whole thing is 56. And it wants us to solve for x. And then once we find x, we'll actually find the length of AB and BC. So to solve for x, we need to set up an equation. And it's going to go back to this theorem. When you add the two segments together, it equals the length of the whole thing. So it's going to equal 56, your equation, because again, it's going to equal the entire length. So we're going to have 4x plus 9 plus 5x plus 2 equals 56. Now, just for the sake of time, so I don't want this to be a super long video, you would solve for x, and you get x equals 5. So there's the first part, x equals 5. Now, to find the length of AB and BC, you're going to plug that 5 in for the x's. So for this first one, it'd be 4 times 5 plus 9, which is 29. So the length of AB is 29. And then for BC, it'd be 5 times 5 plus 2, because x is 5, which is 27. So the length of BC is 27. All right, the last one here, I'm just going to go over really quickly. If U is between T and B, find the value of X and the lengths of the following segments. So again, it says hint, draw a picture. If there's not one there, it's helpful to draw. So we're talking about a segment. And it says U is between T and B. So it's going to look like that. Now it says TU is represented by 2x, and UB is represented by 3x plus 1. And again, they give us the length of the whole thing, which is 21. So to solve for x, we need to set up an equation. It's going to equal 21, because that's the length of the entire thing. And then you add the two segments together to get the length of that whole thing. So 2x plus 3x plus 1. And again, for sake of time, I'm just going to tell you that x comes out to be 4 when you solve this. And then to find the length of TU and UB, you take that value and you plug it in for x. So 2 times 4 would be 8. And 3 times 4 plus 1 is 13. So there's the actual length of those segments.